I'll be doing a brief introduction on the Europa Clipper mission and a kind of a top-down systems overview. So what is the Europa Clipper mission? The Europa Clipper mission seeks to explore Europa, a Jupiter moon, for science of saltwater oceans. It's the largest planetary mission satellite created by NASA, and it was launched on October 14th, 2024. So a little history behind the Clipper mission. Voyagers 1 and 2 were one of the first satellites to properly observe the icy shell on Europa, and later missions such as Galileo further verified it. So the Clipper mission seeks to detect possible water under the Jupiter moon Europa and just further explore it. Some components of the mission, the structural and thermal, are pretty important because they'll be flying through large cycles between Jupiter orbit and a Europa flyby, so they'll be experiencing drastic variations in temperature and effects. Controls in ADCS are also important, as it needs to be pretty precise to make it there. So how it works, it's a highly elliptical orbit around Jupiter, and then it does a flyby through Europa 49 times with science instruments to determine the thickness of the Europa shell and the composition of any potential oceans.
The Europa Clipper uses both passive and active thermal control methods, including MLI blankets, sun shields, thermal control valves, a specialized heat redistribution system, radiators, and a replacement heater block. The Europa Clipper will be exposed to a wide range of temperatures throughout the mission. At the beginning, during the Earth flyby, it is expected to see about 100 degrees Celsius, and at the end of the mission, during the flybys of Europa near Jupiter, it will be exposed to temperatures reaching a minimum of negative 200 degrees Celsius at a maximum distance of 5.6 AU from the Sun. The primary heat sources are the avionics subsystem, scientific instruments, communication hardware, and power electronics, with the primary heat sinks being the heat redistribution system, the propulsion module, and the radiators. It uses a variety of methods to keep thermal equilibrium, which all can be seen here. The combination of the active and passive thermal system allows for additional redundancy and failure protections, with additional heritage components and extensive testing for redundancy.
The Europa Clipper makes use of solar arrays to generate its power. This mission will reach a Jovian orbit where the usable power from the Sun is only 1/25 what we have access to here in Leo. As such, these solar arrays are huge, stretching the length of a basketball court. Jupiter's large magnetic field makes its sphere of influence very radioactive. This was an important factor for engineers to consider. These large solar arrays power all subsystems on board the spacecraft, including a large collection of scientific instruments. During the main part of the mission orbiting Jupiter, the satellite is at its max power consumption. It must generate at least 700 watts. The good news is, according to early numbers during transit, it will generate 1100 watts, which will fall to a predicted 800 watts by the end of its life. This large factor of error builds redundancy for the mission. The spacecraft makes use of lithium-ion batteries to store power for eclipses, flybys, and when the spacecraft needs to point nadir to Europa. These batteries are sized to meet the mission's power and energy requirements. Lastly, the spacecraft has an onboard computer that manages, maintains, and delivers power to all required subsystems. Being this mission is a little more complex than average, different mission phases require different levels of power and different levels of power management. The computer is built to ensure optimal utilization of the available power and balance the power demands across the separate mission phases.
Europa Clipper communicates with Earth entirely through radio frequency using NASA's Deep Space Network with Frontier Radio at its core. It operates on two bands. X-band was chosen for its deep space heritage and reliability, while Ka band at 32 GHz was added specifically to maximize science data return across the 600 million kilometer distance to Jupiter. Both bands sit within the atmospheric radio window, minimizing signal loss through Earth's atmosphere. 7 antennas cover every mission phase, from the low-gain antenna at launch requiring no pointing up to the 3-meter high-gain dish used during science operations. Data rates vary heavily by phase. During sunpoint cruise, rates drop to just 10 bits per second because the antennas can't face Earth. During normal operations, the high-gain antenna pushes up to 357 kilobits per second. At Jupiter orbit insertion, the spacecraft falls back to simple tones. For reliability, the system uses turbo coating for error correction, 4 redundant amplifiers across both bands, and multiple antennas, ensuring a comm path always exists.
In summary, the Europa Clipper mission seeks to explore potential oceans under Europa's icy shell using advanced thermal and communication technology. The technology is needed because of the cyclic loads it undergoes flying in orbit around Jupiter and during its flybys through